All right, today we're going to talk about rational root theorem, how to solve an equation completely, and we're going to talk about multiplicity of roots. First thing, rational root theorem. If we are trying to solve a polynomial equation, and say we don't have a calculator handy, and we need to at least have an idea of where to start because we can't see the graph of the polynomial equation. There is a way to list out all the possibilities, places where this polynomial equation might cross the x-axis. So what we're going to start off and do is, number one, we're going to make sure that our equation is in standard form. We're going to focus only on the first term and the last term. P and Q. The P is going to represent all the factors of the last term in our polynomial equation. These are the numbers that can divide into that term evenly. The Q is going to represent all the factors in the first term, numbers that can divide into that term evenly. After you've listed out all your P's and all your Q's, then you're going to divide every P by every Q. Don't write down any repeats, any identical answers, because there's no need to do that. We're going to put a plus and minus sign in front of every possible rational root. In this first example, I'm going to check and make sure it's in standard form. It is. Descending order by exponent. I'm going to focus on the last term. I'm not going to worry about the sign of this last term, just the number itself. What are all the numbers that can divide into 8? 1, 2, 4, and 8. Now that I've done that, I'm going to look at the Q's. The first term. The first term in this polynomial equation is 1. What are all the factors of 1? Just 1. So for my final answer, I'm going to take all of my P's and I'll divide them by my Q's. And as I do that, I'm going to write down the answers here. I'm going to put a plus or minus sign in front of each of these answers. So I've got 1 divided by 1 is 1. 2 divided by 1, 2. 4 divided by 1 is 4. And 8 divided by 1 is 8. This means that I have 8 possible places where this polynomial could cross the x-axis. 8 possible solutions. Now, just to remind you, the degree tells us exactly how many solutions we have. A degree of 5 means that we will have 5 solutions. These solutions could include these roots that I've listed out, but they could also include some imaginary numbers, and they could include some radicals. All right, in number 2, we're going to do the same thing. Check to see if our polynomial equation is in standard form, and this one is. I'm going to focus on the first term and the last term. We'll start with the last term. We're going to write down all the possible factors of 10. 1, 2, 5, and 10. Then I'm going to look at the first term, 3. What are all the possible factors of 3? 1 and 3. Now, to write out my possible rational roots, I'm going to take every P and I will divide it by every Q. So I've got 1 divided by 1 is 1. Then I can do 1 divided by 3. That's 1/3. 2 divided by 1 is 2. And 2 divided by 3 is 2/3. 5 divided by 1 is 5. And 5 divided by 3 is 5/3. And finally, I've got 10 divided by 1, which is 10. And 10 divided by 3, which is 10/3. Double check to make sure that you don't have any duplicates, any numbers that are written down twice. We don't. And make sure that all of your fractions are written in simplest form. So now that you know how to find the possible rational roots, what can you do with these? We want to be able to look at any polynomial and find all the solutions, all the roots for that polynomial. And so we're going to use these possibles to get us started. To use these rational roots, we're going to do synthetic division. And I've written down a reminder here. Since these are the roots and not the factors, you don't need to change or solve, do anything to these numbers before you use them in the synthetic division. And then remember, if a number divides evenly, no remainder, then it is a root or a solution of the equation. If it doesn't divide evenly, it's not. So you have to keep trying numbers until you find one that divides evenly before you write it down as an answer. Once you find that solution, then you've got options. You could continue trying numbers, or you might want to look at the remaining polynomial and factor it, or even use quadratic formula. So in this example, I'm going to start by identifying my P's and Q's. The factors of 4 are 1, 2, and 4. The factors of 1 are just 1. So my possible rational roots are going to be plus or minus 1, plus or minus 2, and plus or minus 4. So I have 6 possibilities. Now I know there are exactly 4 solutions because my degree is 4. When you're testing your possibilities, you can start with any of these, but I tend to go in order. I'll test out positive 1 first, and then I'll try negative 1. And I'll keep doing that until I find one that gets a remainder of 0. Remember, when I'm testing out a root, I will use it exactly as it is written. If I'm testing positive 1, I'm going to write positive 1. Now, to do synthetic division, we do need to make sure that our polynomial is in descending order by exponent and that we don't have any missing terms. Then we're going to write down our coefficients. In this case, it's 1, negative 2, negative 3, 8, and negative 4. I'll drop the first term below the line and start this process. Multiply, 1 times 1 is 1. Add these two terms together and I get negative 1. 1 times negative 1 is negative 1. Add these and I get negative 4. 1 times negative 4 is negative 4. Add and I get positive 4. 1 times positive 4 is positive 4. And when I add these, I get 0. So we got lucky. The very first one we tried is actually a root, a solution. So I'm going to write it down. My first answer is 1. Now, like I said, you've got options. You could continue testing additional possible rational roots, but I like to factor or use quadratic formula at this point, if I can. So remember, you can take the answer and you can make it back into a polynomial. And the way we do that is we take 1 less than the degree. So this would be x cubed, x squared, x, and then this is my constant. So I have a 4-term polynomial. I could use factor by grouping. So if I want to solve a polynomial by factor by grouping, I'm going to look at 2 terms at a time. I like to just take the first 2 terms and ask, what do they have in common? They're both divisible by x squared. And then I'll do that. What's left? X minus 1. I always write down the sign that's in the middle. It's negative. And then ask, what do these have in common? They both have a 4. So I will divide negative 4 out of each of these terms. And that leaves me with x minus 1. Now, what do these 2 terms have in common? X minus 1. And that leaves me with x squared minus 4. Now, don't forget, a lot of times we have additional factoring that can be done. This is the difference of 2 squares. So it breaks down into x plus 2 and x minus 2. Now that you have everything fully factored, you can solve each of these factors by setting them equal to 0. If I set x minus 1 equal to 0, then I know the answer is x equals 1. I'll go ahead and write that down. X plus 2 equals 0. So my next answer is x equals negative 2. x minus 2 equals 0. So my final answer is x equals positive 2. Now remember, my degree said that I would have 4 solutions, and I do indeed have 4 solutions. Number 4 is very similar to number 3, but it's just a little bit easier because they already gave us a solution. When you're given a solution, you're going to use this instead of having to write out your P's and your Q's. We know this will help us. We can use it in our synthetic division, and we can expect that we will get 0 as a remainder. Don't forget, if they've given you a solution, go ahead and write it down as an answer. Check your polynomial to make sure that your terms are in descending order by exponent and that none of your terms are missing. In this case, we're good. Write down your coefficients, 1, 2, -5, and -6. Drop your first term below the line and start the process of synthetic division. So just like we expected, we got 0 as a remainder. Now, I'm going to take these remaining terms and I'm going to rewrite them as a polynomial. I will use one less than my original degree. So I've got x squared and x. This is a trinomial, which means I have the option of factoring, and if factoring doesn't work, I can always use quadratic formula. This particular trinomial does factor. X squared breaks down into x times x, and I'm looking for two numbers that multiply to a -2 that will subtract and give me a -1. So I've got 1 and 2, and when I am looking for signs, the larger term always matches the sign of the middle one, so -2 and +1. I know they have opposite signs because they multiply to a negative. Set each factor equal to 0 to solve. And my two solutions are -1 and +2. In these last two examples, we're going to talk about multiplicity and how to look at a graph to determine what the roots are and how many there are of each root. Multiplicity is the word that we use to describe how many times a particular root is a solution of a polynomial. And we can determine that by looking at the graph. The first thing you need to do is determine the degree of the polynomial graph you're looking at. You can do this by counting the terms and then adding 1 to that number. The degree will tell me how many roots I actually have. When you're looking at where the graph crosses or touches the x-axis, I want you to determine if the graph crosses it, bounces, or wiggles at that point of contact. A cross is going to look like a straight line. It will only occur one time. A bounce is parabolic in shape. The root will occur an even number of times if it bounces. A wiggle is cubic shape. It means the root occurs an odd number of times. When you total up these multiplicities, make sure they equal the degree of the polynomial. So in order to do number 5, we're going to first talk about how many times this graph turns. Now remember, anytime the graph changes direction, a turn occurs. So we have one there and one here. We have a turn here. This is tricky. Anytime we have a cubic shape to our graph, 2 turns actually occur. So 1, 2, 3, 4, 5 turns, which means this polynomial has a degree of 6. So I'm looking for 6 answers. So what do I look for? I look for where the graph touches or crosses the x-axis. And that occurs at these 3 points. So the shape of the graph tells me how many of each answer I have. If the shape of the graph is parabolic, U-shaped at that point, that means I have 2 of them. If it crosses, then I have a single root. So -1 only shows up once. And if it wiggles, if it's cubic shaped, then I will have that solution 3 times. Total it up. I have 6 answers and I have a degree of 6. So I'm good. On number 6, same thing. Let's count our turns first. I have 1, 2, 3, 4, 5 turns. So this also has a degree of 6. I'm going to look for where it touches or crosses. So I have a root at -3, -1, and +2. How many will I have of each type? At -3, it crosses like a line. So that means I only have that root 1 time. At -1, we have a wiggle, which means it occurs 3 times. And at 2, we have a parabola. It bounces, which means it occurs twice. I total it up, 1, 2, 3, 4, 5, 6 answers, and I have a degree of 6. So I'm done.